Section 2.4, Truth Tables, Conditional and Biconditional Statements, Video 3. In this video, we will cover the following objective. Construct truth tables with 3 simple statements that include conditional and biconditional statements. Previously in this section, we covered basic truth tables for conditional and biconditional statements, and we were able to construct truth tables for statements involving 2 simple statements. And now we're going to talk about how to construct truth tables if 3 simple statements are involved. Example 5, given the statements P, Q, and R, create a truth table for the statement if not Q, then not R, if and only if P. So here we have 3 simple statements, P, Q, and R. So I will make columns for these 3 simple statements. And we are going to label these columns the same way every time for consistency. So for the P column, we're going to do 4 true and then 4 false. For the Q column, we're going to alternate 2 true and 2 false. And for the R column, we're going to alternate true, false, all the way down. This ensures that we hit every possible combination of true and false for these 3 simple statements. Next, we'll see if we have any negations. Notice that Q is being negated and also R is being negated. So I will make columns for those. In order to negate, we just take the opposite truth values. So the negation of Q will be false, false, true, true, alternating. And the negation of R will be false, true, alternating all the way down. All right, next I'm going to make a column for what's in the parentheses, which would be if the negation of Q, then the negation of R. Notice that this is an if-then statement or a conditional statement. Q is the antecedent, the negation of Q is the antecedent, so in other words, the if part. The negation of R is the consequent, which is the then part. All right, so if then, recall that an if then statement comes out false if the antecedent is true and the consequent is false. Notice how that is happening here. So the antecedent is true and the consequent is false. That's also happening here. In those cases, this conditional statement will turn out false. In all the other cases, the conditional statement will be true. Lastly, we will make a column for the entire statement. So if the negation of Q, then the negation of R, if and only if P. So we're putting an if and only if between the P column and the column that we just created. So this is an if and only if. In other words, a biconditional statement. If and only if statements are true when both parts have the same truth value. So here we have both parts are true. Here both parts are true. Here both parts are true. Here both parts are false. Those are the cases where both parts have the same truth value, and so that's where the biconditional statement will be true. If the truth values are different, so if one is true and the other is false, then the biconditional statement will come out false. And that is what the truth table for this statement would look like. We'll do one last example, example 6. Given the statements P, Q, and R, create a truth table for this statement. So of course we're going to have to make columns for P, Q, and R. We are going to label these the same way that we labeled them last time. Notice that we also have the negation of P involved, and we have the negation of R involved. So I know I'm going to need to make columns for those negations. So I'm going to start here. And again, I'm labeling these the same way that I labeled the 3 simple statements in the previous example. We're going to do it this way for consistency. Do it the same way every time. All right, the negation of P would be the opposite of the P column. We'll have the opposite truth values. So 4 false and 4 true. The negation of R would be the opposite of the R column. So false, true, alternating. All right, now I have 3 sets of parentheses. So what I'm going to do is I'm going to make columns for those 3. I'm going to probably run out of room, to be honest, so I'm going to need to create some more space. I'm trying to write as small as I possibly can. But I'm going to make columns for all of the items that are in parentheses. Okay, and then we'll go from there. All right, so we have not P and R. So this is called a conjunction. We're putting an and between those 2 columns. Recall that and statements are true only when both parts are true. So we have that happening right here. So that will be true. We also have that happening right here. So that will be true. That's how a conjunction comes out true overall, is if both parts involved are true. If either part or both parts are false, then the conjunction will be false. So the rest of those will be false. All right, next we're going to have if Q, then the negation of P. So if Q, then the negation of P. Q is the antecedent, the negation of P is the consequent. Recall that if the antecedent is true and the consequent is false, then the conditional statement will be false. Notice I have that happening again here. And those are the only 2 places where that happens, so the rest of these will be true. I like to write if above the antecedent column and Q above, and then above the consequent column, just to keep track of which part is the if and which part is the then, because order matters in conditional statements. Okay, lastly, we have negation of R or Q. So this is called a disjunction. Oops. So that's an or statement. An or statement is only false when both parts are false. So we have that happening there. And we have that happening there. If at least one part of it is true, then it is going to be true overall. So the rest of these are true. And these are rules that have been covered previously, so by now we should be used to all of these rules. We're just kind of putting them all together in a big truth table at this point. All right, next I'm going to work with what's going on in the braces. So that would be if Q, then not P. If, I should say this again, if Q, then not P, then if not R, or then not R or Q. So we're creating an if-then statement. The antecedent is the if Q, then not P. The consequent is not R or Q. So I'm looking for the antecedent being true and the consequent being false, because then this is going to be false overall. And notice how I have that happening in 2 places. The rest of these will be true. All right, and then finally, this is where I'm going to have to extend my truth table a little bit, because I'm going to make a column for the entire statement now. So I think I'm just going to put a star and say that this is going to be the entire statement. Notice that the entire statement is a biconditional statement. So notice how we have this double arrow there. And it is a biconditional statement between this column right here and then the column that we just created. So this is an if and only if. And recall that the biconditional or if and only if statements are true only when both statements have the same truth value. So here they're both false. Here they're both true. And I think those are the only places where the truth values match. If the truth values are different, so one is false and the other is true, then it is false overall. And that's what's happening in all of these other places. And so this is what the truth table, the final truth values, will look like for this overall statement. And this concludes example 6.